Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. In Statistics 1, we have completed first four chapters of your book, and now we are moving towards chapter 5 of your book. The chapter is titled as A Survey of Probability Concepts. So basically, we are interested in learning some concepts that is about probability. So first of all, what we mean by probability. If you see the proper definition of probability, then we may define it as a value between 0 and 1, inclusive, describing the relative possibility, chance, or likelihood that an event will occur. This is called the probability. Basically, if we are interested in knowing that what are the chances or likelihood or possibility of occurrence of any event, then we are interested in, you can say, basically, we want to find out the probability of something. So basically, probability, chance, or likelihood or possibility, these all terms are for same purpose. Okay. So if you see the definition of the probability, the proper definition is there. A value between 0 and 1 inclusive, describing the relative possibility, chance, or likelihood that an event will occur. So this is the definition, but why we are interested in learning probability concepts? This is very important. So first of all, uh, I would like to explain that why are we interested in learning the concepts of probability. Basically, all of us are normally interested in knowing something about future, what will occur in future. So if you are going to take some decision, what will occur, what will be the consequences. So everybody normally is interested in knowing that what will happen in future. So the chance of occurrence of any event uh, basically relates to future. So let us say we are going to toss a coin. So what will occur? It may be head, it may be tail. But if you are going to toss a coin, so whatever will be occur, that will occur uh, a short while after you perform the experiment. After that experiment, there will be some result, there will be some outcome. Okay, so if you consider, let's say, if you are interested, normally we use the probability concepts in inferential statistics, where we infer something about the population based on sample. Okay, so we normally take sample, and based on the results that we find using sample data, we say that this is correct for population. So in inferential statistics, normally we take help of probability concepts. So in probability theory, there are few terms that are of importance, and we want to explain that. First of all, there comes an experiment. What we mean by experiment? Experiment is basically a process. If you say, I may write it down over here. Basically, there are a few terms that we have to remember. So let me write down over here the definition for this. If you see, these are the definitions. So let us read these definitions from your book. A process that leads to the occurrence of one and only one of several possible results. So if let's say you are going to toss a coin, okay, so there are two possibilities. There may be head, there may be tail. So tossing a coin is an experiment which will result in uh, one and only one outcome, uh, and that may be head, that may be tail. So let us say if you are going to roll a dice, you are familiar with dice. If you see dice, I have the shape of dice over here in the slides. These are the dice that you normally use in the game Ludo. So if you're going to roll a dice, there may be one dot up, there may be dots face up, three dots face up, four, five, or six. But there will be only one outcome in form of any number of dots face up. So if let's say you're going to roll a dice and the result is six dots face up, so it means that the remaining five possibilities are not there at the same time. So at one time, one thing is going to occur. So this concept is also called mutually exclusiveness of the events that we will read later on. But here simply see what is experiment, a process. So process means if you are going to toss a coin, so this is a process. You are tossing a coin, okay, and it is leading towards the occurrence of one and only one out of the several possible results. So in this case of coin, there are two possible results, and out of two, only one will occur. Similarly, if you see this outcome, what we mean by outcome, a particular result of an experiment, whatever you are going to get after the experiment, after experimenting something, the result is called an outcome. So a particular result, let's say in case of coin tossing, there is a tail as a result. So you will say that this is an outcome. If there is an head, there is a head. You will say this is an outcome. Okay. Similarly, in case of dice. So these are so you can say this is the story for outcome. So that I have already explained. So there may be several examples. Let's say similarly asking 500 college students if they would travel more than 100 miles to attend a Mumford and Sons concert in an experiment is an experiment. So basically there are 500 college students, uh, and out of them 100 are interested to, let's say, to travel. So what is their you can say ratio, what is their probability? So 100 divided by 500. In this way you can find out. So you may read the example on your own, but we are for the time being interested simply in learning the definitions for the different terms that we normally use. Event, a collection of one or more outcomes of an experiment. So simply, if you simply consider the outcome in case of coin, there may be tail, there may be head. This is an outcome. But if you are interested in knowing what is event, so a collection of one or more outcomes of an experiment. So even one outcome is called event. Okay, and more are also called events. So for example, if you are interested in rolling a dice, so the question may be how many events will be there uh, whose sum will be more than four. So you can count it as let's say if you are going to toss if you are going to roll a dice, so you may write it down as what will be the sample space in that case, as sample space will equal it is quite possible that if you are going to roll a dice twice, so this will be the situation 1 1, It means on one roll there was one dot face up, and on second roll there was one dot face up again. Similarly, one dot, it is quite possible that on second roll there was two dots up, face up, 1 3, 1 4, 1 5, 1 6. So 1 6 means on first roll there was one dot face up, and on second roll there was six dots face up. Okay, so similarly, it is quite possible that 2 1 is there. It means on first roll two dots face up was the result, and on second roll one dot face up was the result. Similarly, 2 2, 2 3, 2 4, 2 5, 2 6. Okay, so similarly 3 1, 3 2, and similarly 4 1, 4 2, 4 3 up to 4 6 and 5, and then 6. Finally there will be 6 1, 6 2, so on up to 6 6. So like this will be the sample space. So now if the question is, so all these are events, so if you see only this one, what is this one? This is an outcome, and at the same time it is an event. And similarly, if you see 1 1, so this is an event. Fine. And if the question is like this, what is the probability that the sum of the outcomes is equal to 5? So then what will be the event? So event will be comprised of different outcomes. So in that case, 1 4, 4 1, okay, 3 2, 2 3. So all these will be collected and written in the in form of some set, and that will be an outcome. Okay, so event. So this is an event, and if you write it down in different way, for example, what is the result in form? Let us say, uh, what are the number of events for which the sum is equal to 6? So you will count 2 2 4, like 1 5, okay, 5 1, 4 2, like this. So collection of one or more outcomes of an experiment. This is called an event. So the further explanation is there in your book. If you see experiment, roll a dice. Okay, count the number of members of the board of. So this is another example. So if you only concentrate upon this, roll a dice. All possible outcomes are. It is quite possible that 1 is there, 2 is there, or 3 or 4 or 5 or 6 different dots are there face up. Some possible events, observe an even number. Observe an even number. So this is an event. Observe a number greater than 4. Okay. Observe a number 3 or less. So as I have explained over here, so these questions are like the questions that I have already explained. So all those will be events. Observe an even number, or you can say observe that the result of the outcomes is equal to an even number. So in that case, you may see that 2 plus 2 is equal to 4. That is an even number. 2 plus 3, that is equal to 5. So that is an odd number. So that will not be written in the result that you will write down. Okay. So this is event. So four definitions are there. In fact, what is probability? Probability is any value that is between 0 and 1. So remember that probability could not exceed 1, and it could not be negative. So it could not be less than 0. It could not be more than 1. It may be 0, it may be 1, or it may be any value in between 0 and 1. So it is also written in form of, you can say, a ratio. For example, 1/7 in case of rolling a dice. What is the probability that one dot will be there face up? So you may write down 1/6, because in total there are 6 possibilities. So out of 6, what is the probability of occurrence of one dot face up? So you may write down 1/6. Or you may write down it as 1 divided by 6, and you may use your calculator to have the answer. So what will be the answer? 1 divided by 6, the answer is 0.16666. So you may say that 16.67% are the chances that there will be one dot face up in rolling a dice once. So in this way, or otherwise, you may write it down in form of decimal, for example, 0.70. Okay, or you may write it down as, in case of one dot face up, you may say 0.16 is the result, or 0.16 you may multiply with 100 to have 16%. Okay, or otherwise you may write 1 divided by 6. So similarly, these are the three ways that you may use to uh, quote the probability, to write down the probability. So then this is the you can say a chart that may further explain the idea of probability. So if the probability is equal to 0, that means the particular event could not occur at all. There is no possibility of occurrence of this event for which the probability is equal to 0. And if for some event the probability is equal to 1, the result is equal to 1, that will mean that there are 100% chances that this is going to happen. Okay, so in between there are different scenarios. For example, for zero probability, the probability that our sun will disappear this year, so during this complete year the sun will disappear, so we may say that the probability for this event is 0. Okay, and similarly, if you see for one chance of rain in Florida this year, or chance of rain in Islamabad this year, so at least on any single day there will be rain. So we are sure that during the complete year, during the whole year, at least on single day there will be rain. So if you are saying that will there be rain during this whole year? Yes, we are certain that at least on single day there will be rain. So as we are 100% sure, so the probability is equal to 1, or it is equal to 100%. So you may write it down as 1, or you may write it down as 100%. So if you see in between, the famous example is of tossing a coin. So the chance of occurrence of head is equal to chance of occurrence of tail, 50-50%. So if the probability for some event is equal to 50%, you may write it down as 0.50 or 50%, or 1 by 2. Similarly, if you see this, chance slowpoke will win the Kentucky Derby. So let's say there is some horse, and you are going to say that there are 20% chances that this horse will win the uh, race. So you may write down it as this. So it means that there are 80% chances that this horse will not win. Similarly, if you see this 0.7, chance of an increase in federal taxes. So it means that 70% are the chances that government is going to increase the taxes in the upcoming financial year. So in this way, we may take help of probability. So you may be, you can say, concerned with the probability. Let's say if this is the situation that 70% are the chances that government is going to increase the tax rates. So accordingly, a businessman may decide something for betterment of his business. Fine. So in this way, probability may help us, that we may decide something according to the given percentage of or chance of something that is going to happen. Fine. So basically, we have some idea empirically. We have some empirical value. So this is very important. Then comes this self-review. Video Games Incorporation recently developed a new video game. Its playability is to be tested by 80 uh, veteran game players. So let's say there are 80 players, and we want to check the playability. So you may say that these out of these 80, how many are saying that yes, it is playable? Fine, we may play it. So the questions are: what is the experiment? What is the experiment in this case? So if you are going to check that, if you are going to interview these 80 people, so this may be an experiment. Or you may count the number of the players who are in favor of the idea that it is playable. So counting the number of players, this is an experiment. Then what is one possible outcome? What may be one possible outcomes? So one possible outcomes may be that 50 players are favoring the idea that the game is playable. So there may be several outcomes, and one possible outcome may be 50 are in favor of this idea that it is playable, or they may be 30, there may be 70, there may be 74, 79, or all 80. So if all 80 are saying that it is playable, so 80 by 80, 100%. Then comes the question: suppose 65 of the 80 players testing the new game said they liked it. Is 65 a probability? No, it is not a probability, because probability could not exceed 1. Okay. So you will say that no, it is not a probability value. Probability. The probability that the new game will be a success is computed to be -1. So again, no, probability could not be negative, right? So your comment will be probability could not be negative. So this is not the value. Specify one possible event. So one possible event may be more than 25% of the players are in favor of the idea that the game is playable. More than 25%, or you can say that more than 30, more than 50 are saying that they are the game is playable. They are favoring this idea. So in this way you may answer these questions. Then approaches to assigning the probability. So basically there are three approaches that are classical, empirical, and subjective. So these are the approaches, and classical and empirical are basically comes under the head that we call objective probability, and the remaining is subjective probability.
Hello.
So for classical probability, the formula is this: probability of an event is equal to number of favorable outcomes divided by total number of possible outcomes. So if you see, if you are going to toss a coin, for example, then which probability type this will be? This will be the classical probability. And why it is classical probability? Because we know that there are total two possible outcomes, and out of two, there may be one favorable outcome in form of head or in form of tail. So number of favorable outcomes, if you are interested in knowing the what is the probability of occurrence of head, so that is the favorable outcome in this particular case. So occurrence of head in tossing a coin once will be 1 divided by total number of possible outcomes. So in case of coin, there are two possible outcomes. One is head, one is tail. So 1 divided by 2. This is the probability of an event. So what is the probability of occurrence of head? You will say 1 by 2. What is the probability of occurrence of tail? You will say 1 by 2. So in first case, number of favorable outcomes will be for head, and in other case, it will be for tail. So in this way. And if you see the example in your book, it is regarding dice. So definitely there are 6 dots, 1, 2, 3, 4, 5, 6 dots on a dice, six-sided dice. So what is the probability that there will be a result that one dot face up is there? So we know that in total the total number of possible outcomes are six. Total possible number of outcomes are six. So it is known. We, before performing the experiment, we know this. Before experimenting this, we know this, that there are six possible outcomes. Now, one by one, what is the chance, what is the likelihood, or what is the probability of occurrence of four dots face up? So we know only one. So 1 divided by 6. Okay. And if you see over here, there are three favorable outcomes, a 2, a 4, and 6, in collection of six equally likely possible outcomes. Therefore, probability of an even number. So now, as even number is there in consideration, so you would see that how many even numbers are there on the dice. So 6, 4, and 2. So these are the even numbers. So as these are three in total, and total number of possible outcomes are six, so 3 by 6. If similarly, if you are interested in finding out the probability of an odd number, so odd numbers you will count 1, 3, and 5. These are the odd numbers. So 3 by 6 again. So 0.5 is the answer. Then comes the idea of mutually exclusive events. So remember that mutually exclusive, mutually means together. Exclusive means to exclude something. So it means that if one occurrence or one event is going to occur, the other event will not occur at the same time. So if again you take into your account the example of coin, so I would say that the head and tail both are mutually exclusive. Why mutually exclusive? Because if tail is going to occur, then head could not occur at the same time. If head is going to occur, tail could not occur at the same time. So if such is the situation, we will say that events are mutually exclusive. Events are mutually exclusive. So proper definition is there. The occurrence of one event means that none of the other events can occur at the same time. Okay. So you may take the example of coin, or you may take the example of dice. In case of dice, again, if three dots up, three dots face up is the result, then no other event will be there. No other outcome will be there at the same time. So at the same time, only one outcome will be there. So if this is the situation, you will say that events are mutually exclusive. Then there comes the definition for collectively exhaustive. So these definitions will be used later on when we solve different examples and different scenarios. You will see that how these are important to solve different situations. So if I think somebody's mic is open, so please check your mics and off it so that we may
Yes, sir.
avoid this noise that is there in the recording. So please turn off your mics. Collectively exhaustive. At least one of the events must occur when an experiment is conducted. So it means that, again, as in case of coin, the head and tail, these two are mutually exclusive. If one is gonna occur, the none of the other will occur. It means if head has occurred, the tail will not occur at the same time. And similarly, what we mean by collectively exhaustive. So collectively exhaustive means if you are going to toss a coin, so there will be an outcome, and it is must. If you are going to toss a coin, so there will be some result in form of head or tail. It is not possible that there is no head is not there and the tail is not there at the same time. No, at least one will occur. So this is the definition. At least one of the events must occur when an experiment is conducted. So if you are going to roll a dice, at least one outcome will be there. So collectively exhaustive means at least one will be the outcome when you are going to perform the experiment. So this is collectively exhaustive. Then comes empirical probability. So in case of empirical probability, basically empirics are involved, or you may say that you have some value based on the experience that you have from past events. So let's say if you see this definition, the probability of an event happening in is the fraction of the time similar events happened in the past. Okay. So how many times the same event has occurred in the past? So what is the probability that this will occur in the future? Okay, so based on the past experience, we may forecast, we may say that this event is going to occur in the future, and these are the chances. This is the percentage. This is the likelihood. This is the probability that this event is going to occur again in future. So the idea regarding empirical probability will be further clear when we will solve an example for this. But as we are moving onward, you simply see that what we mean by law of large numbers. So this simply means that if you are going to uh, perform an experiment so many times, so the empirical probability will approach its true probability, and true probability is basically the classical probability. So there is an example, and number of trials 1, number of heads 0. The relative frequency of the heads is 0. Relative frequency means probability in this particular case. No problem. You may think it as relative frequency or probability, same thing. Then number of trials, if you are going to toss a coin 10 times, then it is quite possible that 3 heads are there as a result, and 7 times tails were there. Similarly, you are going to increase the number of trials. Let's say you are going to toss a coin 500 times. What will occur? Let's say 236 times head was there. It means remaining uh, were the number for the remaining number was for the tails. So 500 minus 236, whatever is the answer, that you may say that those will be the number of tails. So 236 divided by 500, the answer is 0.472. So you may see that as you are going to increase the number of trials, the probability is moving towards 0.50. Let's say 10,000 times you are going to toss a coin. The result is, and out of 10,000, 5,027 times head was there. So 0.57, 0.5027 is the result. So 50%. So what we mean by law of large numbers? So it means that as many times we are going to perform the experiment, the empirical probability will move towards the true probability, and that is the classical probability, basically. Now come to
Sir,
this example. Now come to this example, and I want to solve this example. So I may take it to Word.
sir, 5 question, sir.
So please write down your question on your notebook, and when I will finish this lecture, then I will have the question answer session. So you may ask, you may pose all your questions at that time.
Sir, I have a question, sir.
Okay, fine. Ask.
Sir, if we toss 10 times of a coin, so if we got 10 times of heads, so what would the empirical probability of that, sir?
Before I explain the empirical probability in detail, this question is not appropriate to ask at this time, because I am still explaining the empirical probability. So there is some difference between empirical and classical. In case of classical, we know that what are the total possible outcomes? What is the number of total possible outcomes? Fine. But in case of empirical probability, we basically base on the past events. So that is what I am going to explain right now. So better would be if you wait for a while and see that what is the explanation, or you may see that what I'm gonna explain regarding empirical probability. So this is the question that I want to solve regarding empirical probability, so that the idea is further cleared. On February 1st, 2003, the space shuttle Columbia exploded. This was the second disaster in 113 space missions for NASA. On the basis of this information, what is the probability that a future mission is successfully completed? Okay. So you can see that this is an entirely different situation. In case of coin or in case of dice, we know that if you are going to toss a coin once, there are two possible outcomes. If you are going to toss a coin twice, there will be four possible outcomes. If you are going to toss a coin three times, so 3 power 2, 2 power 3, the result is 8. So in that way, you may find out that how many total possible outcomes will be there. So let's say if you are going to toss a coin two times, let's say you are going to toss a coin two times, so you will take 2 power 2, the answer is 4. Okay. So the sample space you may write down head. This is one event, head tail, or tail head, or tail. So these are the possible outcomes or events. Fine. So if you are going to toss a coin, let's say for three times, so what will you do? 2 power 3. As 2 is the uh, 2 are the possibilities, the possible outcomes, and you are going to toss a coin three times, so 2 power 3. If you are going to toss a coin four times, 2 power 4, like this. So basically, we know that what will be the total favorable outcomes in tossing a coin once or twice or thrice or four times, like this. Similarly, in case of dice. But in this case, if you see, 113 space missions. Okay, so this is the information that based on, you can say, past evidence. So we know that 113 space missions were there from NASA. And what happened out of these 113? This was the second disaster in 113 space missions. It means out of 113 space missions, two space missions were failed, or you can say the shuttle destroyed. Okay, so total space missions 113. Out of 113, two times the mission failed. The missions failed twice. Total 113 missions. So what will be the probability that during the next flight, during the next mission, the mission will be successfully completed? So for that, you may depend upon this information. How? You will write down, you first of all write down, let A be the event that uh, mission or space mission will be successfully completed. First of all, you will define the event in this way. Then what is the probability that next time it will be a successful mission? So you will write down probability of A, and now you will use the empirical probability formula, the formula that is given for empirical probability. And the empirical probabilities formula was, what was the formula? Number of successful flights in this case and total number of flights. So the formula in that case was number of times the event occurred. Number of times event occurs and divided by total number of observations. So total number of observations or total number of flights or total number of missions in this particular case was 113. And what is the probability that the space mission will be completed successfully? So if you see, the question was like this: what is the probability that the next mission will be failed, or there will be disaster? So you will write down 2 in that case. But in this particular case, 111 you will write down over here. Why 111? Because twice there was disaster. So it means that 111 times the missions were successful. So you are interested in finding out the probability regarding the mission that will remain successful. So how many times mission failed? 2 times. How many times out of 113 mission was successful? 113 minus 2. The answer is 111. So 111 divided by 113. So whatever will be the answer, that answer will give you the chance, or the you can say the probability, that the next mission will be completed successfully. So let us divide this. The answer is 0.98. So you may say the next mission will be completed successfully, and we are 98% sure regarding that. Right? And if the question was, what is the probability that the mission will be failed? Let us say I'm going to rephrase this question as, what is the probability that a future mission is successfully completed? So I'm rephrasing this question. What is the probability? Now the question is, what is the probability that the future mission will be failed? Okay, so you will take help of the past experience. Twice mission failed out of 113 missions. So in that case, again, you will define the event. Let A be the event that the mission will be failed. The next mission will be failed in that case. Or you may define it, let B be the event that the next mission will be failed. First of all, you will write on that statement, and then you may find out probability of B. What is B? B is the event that mission will be failed. There will be disaster for the next or for the future mission. So it based on the past experience. In past, out of 113, twice it has occurred that mission was failed. So 2 divided by 113. So if you have calculator with you, you can find it out.
0.017.
Answer is
0.17.
point
0.017.
017.
9.
0.176917. So you may say that 1.77% are the chances that the next mission will be failed. So very minute chances of disaster. Fine. So in this way, you may take help of probability formula, that is for the case of empirical probability,
Sir, again,
and
sir, little bit,
decide that
sir.
what will happen in future.
Sir, hello.
Yes, yes, boy. Yes, boy.
Yes, sir. Sir, I can understand, sir. Again, sir, little bit, sir. It's different. It's difficult, sir.
Which one?
Sir, the first question, sir. The question, sir. That question, sir. This one, sir. Yes.
This question?
Yes. How to solve, sir? Little bit, sir. Yes.
Okay, don't worry. Let me rephrase the question. So first of all, you have to distinguish between the empirical probability and the classical probability. In case of classical probability, we know before the performance of any, before performing any experiment, we know that how many outcomes are possible in total. Okay, let's say in case of tossing a coin once, we know that there are 2 possible outcomes. In tossing, in rolling a dice Once we know that there are 6 possible outcomes. We before performing the experiment we know this, but in case of empirical probability, we don't know. There may be a space, the number of space missions may be 113, they may be 139, maybe any. So it depends upon the past experience. So let's say NASA sent space missions or space shuttle 139 times, okay, in past. Okay, so let's say before, if you're not in 2003, so you may say that in 2021, on February 21, the space shuttle Columbia exploded. Okay, so let's say this is the information: exploded. This was the second time or second disaster in 139 space missions. So it may be, let's say, you may say that this was the um, uh, fifth, let's say, fifth disaster in 139 space missions for NASA. On the basis of this information, let's say, if you are going to consider that NASA, if sends its mission in space in future, so what will be the probability that the space shuttle will explode? It will not complete its journey. Okay, when you will use the probability concept, so you may find out that what are the chances that the next or the future mission will be failed. So how can you take help of uh, this story? Total space missions were 139. So first of all, you will write down the event. You will write down the event that is required. Okay, so you may write down over here, let solution. So you will write down, you will start from here. Let A be the event that the mission will remain or will be failed. Will be failed. Will be failed means the shuttle will be destroyed. It will not complete its journey successfully. So let A be the event. So now you will use this A. How you will use this A? You will write down the probability. How? Probability of A. This is required. So now what this means? In future, so the information was there regarding past, historic information was there, and you are interested in saying something about future. So what will occur next time if NASA is going to send its if NASA is interested in sending its shuttle into the space? So you will see that how many times shuttle destroyed. You will see that
5 times.
5 times. So you write down over here 5. How many total missions were there? 139.
139.
So see what is the answer? Point zero three
0.035997.
9. Okay, so you may say that 3.59% are the chances that the next mission will remain,
Will be failed.
will be failed,
Failed.
will remain unsuccessful. Fine. So if the question is like this, what is the probability that the future mission? No. This was the answer for. I have to change this for this result. What is the probability that the future mission is? Let's say I have to change this statement. Is unsuccessful. If this is the question, then you will answer it like this: unsuccessful, because you are defining the event as let A be the event that mission will be failed or will remain unsuccessful. Okay, so you will solve it in this way. But if the question is what is the probability that the shuttle will complete its journey, let's say the question is like this: what is the probability that the future mission
सर एक्सक्यूज मी सर, ये 139 कहाँ से आया सर?
139 is there in the question. I have
तो
written it on my own. I have simply changed the data.
ओके सर, ओके।
What is the probability that a future mission is successful? So now how will you find out the probability for this? You will write down, first of all, let. You will write down let. In this case, you may again define the event with A, or you may write down uh, it as let B be the event. Let B be the event.
Excuse
That the
me, sir.
mission will be successful.
Excuse me, sir.
Yes. That's why I'm listening.
Sir, why you are separating probability into two ways like A and B?
It is mandatory because if you are not going to write it down as B, what would you have to write down? Let us say I'm going to write it down as probability of B. Otherwise, you would have to write down it completely. What will you write down instead of B? You will write down as
So
this:
we can write
mission,
probability of
probability
success and
that
probability of
mission will be
successful.
completed successfully. Fine. If you are not going to write down B, or if you are not going to define the event, then you would have to write down this whole statement: mission will be completed successfully. Fine. So whenever you will write down probability, so these 1, 2, 3, 4, 5, 6, 5 words will be repeated again and again. To avoid this situation, we are simply defining the event so that we avoid the situation that we are not interested in writing this again and again: mission will be completed successfully or mission will be failed. So we want to avoid this situation. We don't want to write down this again and again. We simply want to write down B. So B means this. Okay.
Yes, sir. Thank you.
So therefore, we define events first, and then we use those, whatever we define, we use that, so that we don't write the statements again and again. So in this particular case, probability of B, as we have defined that mission will be successful. So you have to see the question: how many times mission was successful? Definitely 5 times. It was not successful. So 139 minus 5.
134.
139
134.
minus 5. The answer is 134. So 134 times mission was successful. So you write down here 134 divided by 139, the total number of flights or total number of missions. So 134 divided by 139, the answer is 0.9640.
0.964.
So you may say, when you will multiply this figure with 100, the answer will be 96.40%.
96.4%.
So you will put this percent sign with this, and you will say that there are 96.40% chances that the future mission will be completed successfully. So you may see that how probability concepts are helping you. And finally, the subjective probability is there. So basically, if I write down it as probability, so you may say that there are two types. One is objective probability, and the other is subjective probability. So under that subjective, there is no detail. I will explain it later on. But under this head, objective, uh, there are further classification. There is further classification. One is called uh, classical probability, and the other is called uh, empirical probability. So we have seen both cases, empirical and classical. So now we are interested in learning that what we mean by subjective probability. So basically, the subjective probability based on the experience of anybody who is, you may say, an expert in some area. So we may say that this is the statement, or this is the information given by that particular person who is expert in that particular field. So we may depend upon that. So basically, if you see the definition for the subjective probability, that is this: the likelihood or probability of a particular event happening that is assigned by an individual based on whatever information is available. So let's say, if I ask somebody that what are the chances that rain will occur tomorrow? Okay, so everybody will give his answer, and he will guess. He will make his best guess to answer this question. But if I contact with some person who is expert in this field, uh, so he'll give me the answer according to, let's say, some information, latest information. So he may see that the clouds are coming from west, and this is their speed, and they are going to uh, reach, let's say, in this particular area at this particular time. So there will be rain, okay, or there will not be rain. So everybody will answer the question according to his own experience. Okay, so an old person, let's say, may feel the you can say the air, the coldness of the air, let's say, or temperature, and then he may say that there are chances of uh, rain. Okay, or the wind is like this, it is flowing in this way, the wind is like this, so there will be rain. So everybody is free to make his own opinion. So this is called the subjective probability. Estimating the likelihood the New England Patriots will play in the Super Bowl next year. So it depends that whether they are going to play or not. Okay. So some people may say that yes, they will play. Some may say they will not play, or some may say that 70% are the chances that they will play. Some other person may say that no, there are 30% chances that they will. So everybody make his own guess. So this is the subjective probability that does not base on some experiment. Basically, it depends upon experience. Estimating the likelihood you are involved in an automobile accident during the next 12 months. So let's say being uh, some expert driver, you never indulge in some accident, you never faced an accident because of some because you know how to drive. So then somebody may say no, there are 0% chances, or somebody else may say that no, there are 10% chances. So everybody may guess on his own. Okay. Estimating the likelihood the US budget deficit will be reduced by half in the next 10 years. So again, we can't say something uh, with, uh, with confidence about this. There may be a decrease of, you can say, 50% decrease, or there may be 40% decrease, there may be 10% decrease in the budget deficit. So we can't say something with sure regarding such situations. It depends upon experience. So again, this is the chart that I have already explained based on available information. Okay, and objective, under objective head, classical probability is there, empirical is there. Empirical probability based on relative frequencies, and it based the classical probability based on equally likely outcomes. Equally likely outcomes means if you are going to toss a coin, so chance of occurrence of head or chance of occurrence of tail, both are equal, they are equally likely. So if such is the situation, then classical probability is there. And empirical probability based on the relative frequencies. So as we have done that, the 139 missions were there. Out of 139, 5 times mission failed. So 5 divided by 139. So relative frequency, in relative terms, we find it out. Okay, so this is all for today, and we may solve this question if you have time. One card will be randomly selected from a deck of 52 cards. Uh, what is the probability? The card will be a queen. Which approach to probability did you use to answer this question? So in detail, I shall explain what we mean by cards, because some students are not familiar with cards. So basically, cards are there, and there are diamonds and hearts and clubs, and these are 52 cards in total. Uh, so out of these, we will solve different questions. But let's say there are 52 cards. What is the probability? The card will be a queen. So in spade, in diamond, in club, in hearts, in every pack, there are one queen. So four queens are there in total. So 4 divided by 52 will be the answer. So this is the example that is regarding classical uh, probability, because we know before performing or before selecting the cards, we know that in total there are 52 cards. So this is an example of classical probability. Fine. So 4 divided by 52 will be the answer, or will be the required probability. Why 4? Because there are 4 queens. So I shall explain this idea in detail later on. If you see this question, the Center for Child Care reports on 539 children and the marital status of their parents. There are 333 married, 182 divorced, and 24 widowed parents. What is the probability a particular child chosen at random will have a parent who is divorced? Which approach did you use? So definitely in this case, you will use the empirical probability.
Empirical.
Empirical
Okay.
probability. Fine, because divorce may be more than 182, married may be less than 333, widowed may be more than 24. Okay, so but in this case, if you see 52, there are always 52 cards are there in deck. Okay, but in this situation, the number of divorced, number of widowed, number of married people may be different. Okay, so if you are going to select one child at random, what is the probability that the parents of this particular child are divorced? Okay, so you will see that how many are divorced? 182. Okay, and how many total children are there? 539. So 182 divided by 539. Okay, this will be the answer. Then what is the probability you will save $1 million by the time you retire? We are not sure. You are not sure about this. You may say that I am going to save, let's say, 50 lakh after 10 years when I would be retired. Okay, but that figure may change. So this is your guess. But at the time you are going to retire after, let's say, 30 years, then the situation may be different. Okay, so which approach to probability did you use to answer this question? Subjective. Everybody is free to have his own opinion. There are 70% chances that I'm going to save 50 lakh after 30 years when I would be retired. So this is the probability that is, you can say, the subjective probability. So you may solve these questions, or otherwise, inshallah, in next class, we shall try to solve these questions one by one. And then there are so many other things in the survey of probability concepts that we shall explain in detail in the next class, inshallah. So thank you very much for your patience.
सर ये रिकॉर्डिंग भी शेयर करें सर।